I just pulled a 50-row financial table out of a scanned PDF with zero structural loss in just 5 lines of Python. You know that feeling when your RAG system hallucinates. Then you realize the PDF loader just mashed a beautiful table into a single text block. Standard loaders destroy structure. Today we're fixing that using vision models to parse documents exactly how humans read them. So here is the thing. Standard parsers just rip text from left to right and completely ignore the layout. We are using LlamaParse instead. It actually looks at the document using a vision model, and this identifies tables, headers, and charts before extracting a single line. Now your vector database gets clean markdown with all relationships intact and the context survives. Alright, let's look at the pipeline. The document goes into our parsing agent first. The agent uses vision to map the structure and returns perfectly formatted markdown. Then we just feed the markdown straight to LlamaIndex for our RAG setup. Notice that we do all the heavy lifting before vectorization, but the best way to learn this is to write it. Let's get the project set up. We are using LlamaParse because the newer cloud packages are completely broken right now. We need that, and we also need LlamaIndex for vectorization and python.env. Next we create the .env file and we specify the Llama Cloud API key for the vision extraction. OpenAI is required too because LlamaIndex uses it for embeddings by default. Next, inside the pipeline.py we start writing the pipeline. We put all our imports at the top and load the environment variables. Then we initialize to LlamaParse. Notice the parameters here. We request markdown output, turn on multimodal model and explicitly set the model name to OpenAI GPT-4o. This is the key detail. This configuration tells the engine to use vision models to actively look at the page layout instead of blindly scraping characters. That is how the tables survive the extraction process. Now we actually run the parser. We call load data and pass our file path. Behind the scenes, the document gets uploaded to the API and processed by the vision model. It returns a list of document objects containing the extracted text. We grab the first document and print a snippet of it. This lets you see exactly how the tables are formatted before they ever reach the vector database. I have prepared a financial report PDF and uploaded it to the GitHub repository so you can use it. We have a clean markdown now, but if we chunk it blindly by character count, we might split a financial table right down the middle. That ruins the context. LlamaIndex has a specific markdown node parser to solve this. It splits the document based on headers instead of row length. We just pass our parsed document into it. This guarantees that parent and child relationships in your data stay together in the exact same chunk. So here is how the whole thing flows together. We take those perfectly structured nodes and build our vector index. Since the chunks align with markdown headers, the embeddings accurately represent distinct sections of your document. A table and its surrounding context remain intact. From here, we turn the index into a query engine. Now the model actually has the right structure to read from when you ask a question. Our question will be what is the Q1 revenue in the table. Let's now fire it up. Run the Python script from your terminal. You can safely ignore the deprecation warning at the top. You should see the raw markdown output first, showing your tables perfectly formatted. Right after that you will see the answer to the query. The LLM parsed the data correctly because it received a clean table and was able to answer our question accurately. Alright, let's look at what you've got. You now have a document pipeline that actually respects enterprise formatting. Messy tables and nested charts don't break your RAG system anymore. The vision model structures them into clean markdown first. Your vector database finally has context it can understand. Next step, try running this on the absolute worst PDF you can find at work. See how it handles merged cells and weird columns, and stop blaming the model for hallucinations when the input data is broken. And if you want more stuff like this, hit subscribe. I'll catch you in the next one.